third lesson is using formulas and possibly using a computer output to answer questions about certain sets of data that have lines of best fit. Okay, and we know that the least squares regression line equation, or just the equation of a line, is y equals mx plus b. In this case, we have a y hat, just to show that this is a prediction and not an actual value. Okay? Now, very important to know that with your least squares regression line, there's always a point that you'll be able to find. This x bar and y bar. These are points that will always be on your line of best fit. Okay, we didn't go into how you found the line. We just used our calculator to find the line. But the line includes the means of your x and your y. Okay, these x bars and y bars are the means. Okay, and this is always a point on the line of best fit. Okay. So we went back to our example that we did at the beginning of class with shots per game and goals per game. The mean for the shots per game, whatever that would be, and the mean for the goals per game, you put them in a point, that point would have worked in this equation. Okay? So that's good to know. That means that we will be able to calculate the y-intercept knowing this point by just taking the y and subtracting the slope times the x. So the y minus the slope times the x will give us the b. This is one equation that we will use to help us find the y-intercept. You'll find that that equation is not so important so long as you know that we have this point and we'll be able to find our slope. And our slope is found using this equation. This is always the slope for the line of best fit. I believe our friend Party Sabetti told us about this, and we had to not worry about it, but now we kind of have to worry about it because this is going to help us generate our equation if we're given information. We know that R is the correlation. We know that Sx and Sy, this is S sub x, this is S sub y, they are the standard deviations of the x and y variables. Remember, standard deviation is the typical amount of distance from the means, or the mean for the variable. Okay? So, if we went back on our previous example, if we calculated the standard deviation of a x, we calculated the standard deviation of a y, if we calculated the r, we would be able to use those 3 points to get 0.085, which is what your calculator did. Okay? And really, if you have those, if you have your data set and you can calculate standard deviation, you can calculate the correlation, you'll be able to produce your equation. But we're still going to use our calculator for all of our problems. We just now know maybe if I am given data, I'm going to be able to figure out your equation. Okay? Now, it's very important to understand what is going to be x and what is going to be y. Okay? It's very important to determine which one will be x and y. In some cases, it won't matter. But in some cases, there is going to be a clear explanatory response relationship. If so, explanatory we know is the x and response is the y. For the previous example, there is a clear relationship. We wanted to show that goals came from shots, or shots produced goals. So shots were my x, that's my explanatory. Goals was my y, and made sure it is addressed as such. But sometimes it is not clear. Our first example, it's not going to be clear. If we're not sure what is going to affect what, or what comes first and what we're trying to show, if we're not sure about that, typically we will always use the equation to predict a y. So we're going to look at what we are trying to predict, and that is what we are going to put for y. Okay, here comes our first example. In 2000, the mean verbal score for all SAT 1 test takers was 505 with a standard deviation of 111. For math, the mean was 514 with a standard deviation of 113. The correlation between the two scores was not given, but it's known to be quite high. I'm going to look at A, B, and C, because right now, just by looking at it, we have these math SAT scores and these verbal SAT scores. Well, I can't think about a relationship with one causing the other or one explaining the other. So right now, I'm not sure there's a non-clear relationship, okay? There's no clear response or explanatory. So I look at what I'm trying to find. Well, we want to find the equation of the regression line. Okay, well, that'll just be y equals mx plus b. We'll find that in a second, but that doesn't help me. Part B, it says use the equation to estimate the math score from a student's verbal score of 550. All right, here we go. We want to predict the math score. Because in this question, I want to predict the math score, I'm going to say that the math is going to be my y variable. Whatever we're trying to predict, we'll say is y. That means the verbal is going to be my x. That's the first thing we need to do, is kind of determine what is y and what is x. Okay? Now, we're going to use our data and make sure we know what data we have. So I'm going to label my data. We're told the mean verbal scores is 505. Well, if verbal is x, the mean verbal score would be x bar. And that's 505. The standard deviation is 111. So that would be the standard deviation of my x's, 111. Notice, I can't just start writing stuff down until I know what is x and what is y. X is verbal, y is math. Now for math, the mean was 514. That is going to be my y bar, the mean of my y's. And the standard deviation, or S sub y, is 113. It's important to make sure that data is labeled. We want to find the equation of the regression line. Well, I know I need y equals mx plus b. Well, I'm going to first find m. M is going to be done by using this equation. M equals r times sy over sx. That's just what is going to be. M equals r. Here we're told the correlation is 0.7. Sy, 113 over Sx, 111. And we go ahead and use our calculators to find that. Somebody do that for me and tell me what we get. $7.19.
I divided it by 11 and said 111.
0.719. 0.713. Okay, good. Next is going to be to find B. It's simple if you use M and then the point X bar, Y bar. Okay, so we know we have the equation and you can go straight to this. However, some students just forget this equation. Instead, you know y equals mx plus b. The only thing you need to know is this m equation. You can say, okay, well, y will equal 0.713x plus b. I know that the point 505, comma 514 is a point that will work here. Well, I can plug in then 514 for y and 505 for x to find b. Yes, 514 equals, that's the y, equals 0.713 times the x, 505 plus b. So it turns out to be just like we have above in our formula, is your y bar minus your m times your x bar. And we get 153.935, giving me my equation, y equals 0.713x plus 153.935. And that's what I'm trying to find. Notice, like, a lot of steps. Do you have to write all this work to do all this? No, of course not. You could do this a little bit quicker as long as you know what's the equations you need to use and how one thing is going to relate to the other thing. Okay? All right, well now part B, that's kind of what is leading us, this part B, is use the equation to estimate the math score, which is a Y, from the student's verbal score of 550. So, what is Y when X is 550? Just like we did with all these problems and just like you did on your quiz, it's the same deal. And what do we get? Check your answer with a neighbor. What do we get? Just plugging in. 546? Okay, 546.085 or something like that. Okay, so it turns out most students, so I guess in this situation, most students' math score is going to be below their verbal score. Is that true? Raise your hand if your SAT verbal was higher than your SAT math. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 22. Hit half and half, 50%. So they're really similar scores. They're almost like the same. So it looks like SAT math and verbal are probably going to be close to the same. That was not the case for me. Interpret the slope. Slope, remember, just like last class, we can interpret the slope. We have the slope is 0.713. We put it over 1. We say this is my rise over my run. This is my y's and my x's, and I hope you got this question or these questions right on your quiz. You'd say, for every 1 increase in y, y in this case is your math score, there will be a 0.713 increase in x. X is your verbal score. Okay? Interpret the Y-intercept. Remember, the Y-intercept is when x is 0. When x is 0, if you scored a 0 for your verbal, your math score would be 153.935. And again, this Y-intercept is very, very far away from our data. We would say this doesn't really make much sense. Does not compute. Okay, your turn. Number 2. At her high school, Sarah Bellum is enrolled in both physics and calculus. The scores on her physics exam are approximately normal distributed with a mean of 175 and a standard deviation of 12. Scores on the calculus file are also normally distributed with a mean of 80 and a standard deviation of 8. I wonder what the mean of 175 was out of. Anyways, it is Also known that the correlation between the physics and calculus grades is 0.92. So apparently if you're good in physics, you're going to be good in calculus. Sarah Bellum scored 181 on the physics final. Predict what her score would be on the calculus final. What would the score be on the calculus final? That is what I'm going to say is my Y. Okay? So calculus turns out is going to be the Y. That means my physics is my X. Let's go through the steps. We know what is Y and what is X. Second step, we're going to list all my data. Or label my data. That's what it says, label my data. Then we're going to find M, and then we're going to find B. Then we're going to use Y equals MX plus B to predict the thing that we're missing. How are we going to find M and find B? We're going to find M using this equation. We'll find B using either this equation or just the fact that we have a line and we have the point X bar, Y bar. Ready, set, go! Label your data. Check your answers with a neighbor. We should find a slope of 0.613. Once you find your slope, use your slope and your point, which is X bar, Y bar, to find your Y-intercept. And then you go ahead and use that model to predict the calculus score when physics was 181. Yep, take that, subtract that.
Yeah.
That's okay.
Okay.
Your B appears to be negative. Is that correct?
Yes.
Yes. This is why those Y-intercepts, even though we can interpret them, most of the time they're not going to make sense. It means if we get a 0 on my physics score, my calculus score would be negative. That doesn't really make sense. That's your M. Once you have your M, remember you have your point, X bar, Y bar. You can use this as an X and a Y in your equation to find B. y equals mx plus b. You have m, so y equals 0.613x plus b. And that's your final answer?
Confused what I do from here.
So that's your b. Now you have your equation, y equals mx plus b. Now you use that equation. You find your m, you find your b. What do we get for b? Negative 27.275. Now, see, a lot of people kind of pause right there. They're not sure what to do. Well, you have your equation. You have m and you have b. So here's your equation, your prediction model. Y equals mx plus b. Right? Here is your prediction model. Remember what y was. Y was our calculus scores. What was x? X was our physics score. The question was predict what her score would be on the calculus final, given that her score was a 181 on her physics final. Well, plug in 181 for physics, find calculus. And we get 83.678. First thing we should be asking ourselves, does that score make sense? Yes. It's right around kind of her physics score, which was an 80. Okay? Well, right around the mean for physics, which was 80. So we're greater than the mean for physics, just like we are greater than the mean for calculus. The calculus mean was 175. Okay? All we had to do is find our equation. Once we have our equation found, we use that as our model. Okay? Okay, moving on. In the future, perhaps you might use programs. Now, your calculator kind of has programs in it. And your calculator spits out information just like we've seen. The ax plus b, the r squared, the r. Well, computer programs will do the same thing as calculators, just the data will be spit out different ways. Here are two outputs for computers. Okay? Let's talk about what the computer's putting out. We have this one and then the next one. Examples of outputs from computers of a data set. We're talking about the management of a chain of package delivery stores would like to predict the weekly sales in thousands for individual stores based on the number of customers. Okay, so we're trying to predict the weekly sales. That's going to be my y. In terms of number of customers, that's going to be my x. It's very important to understand the y and the x. Linear regression has been done in 2 statistical computer programs, and the output is shown below. Okay. Here's what we need to get at. There's a lot of values here. A lot of the stuff we will not use. We just got to be able to find the stuff that we want to use. The stuff that we want to use is right here, as well as, where's the r square? Right here. Okay, we got the r squared, and then we have what was called the intercept and customer. Okay, well, we talked about the customers as being the x, right? Well, this is going to be the value next to x. This will be our slope, m. And the intercept, well, that's our y-intercept. That's when our x is 0. This would be our b. Our R square is 0.9119. Our R is going to be equal to the square root of that value. Now, what's the square root of 0.9119? 0.955. Now, when we take the square root of something squared, this is R squared, right? We should get either a positive or a negative value. Well, either we can know what it's going to be by thinking about the certain situation that we have, whether it's going to be a positive or a negative relationship, or we can look at our slope. Now, let's look at our original question. We want the sales from individual stores based on the number of customers. Do we think that's a positive relationship or a negative relationship? What do you think, Mr. Johnson?
Positive.
Positive. As customers go up, sales are going to go up. So from that, we should know that this is going to be a positive 0.955. That's important to know. Okay, so intercept and customer, that's what we get. Down here on the next graph, some outputs will actually go ahead and give you the equation, y equals ax plus b. In this situation, they don't. However, you will see the same kind of information from this computer output as we saw before. We have a constant and a customer. The constant is really another word for the intercept, just like in the previous one. Intercept. This is going to be that y-intercept when x is 0. That's our b. And our customer, you can see that same value, that 0.0087, just like we saw here, 0.0087. That is my m. So you can just kind of see that. So now, what would have been shown if they had shown it, the regression equation would have been 0.0087. Now, they'll either say x, or they'll write customer plus 2.4235. Now, customer is just x. It's just saying what x is equal to. And you'll see when we do our homework, there will be an example with an equation that has the word instead of x. It's just kind of flip-flopping it. Okay? So for part A, we can answer part A. Determine the regression equation. Well, either you'll be able to see it up here, or you're just going to have to look and see the predictor. You'll see it under predictor here. Up here, you'll see it under parameter estimates. Okay? The regression equation y equals mx plus b. In here, it'll be 0.0087. You can either write x or customer plus b. Now, what's really important is for this question, just so you're not confused, this question is weekly sales in thousands. In thousands. So, if I'm asked to interpret my slope, well, my slope is 0.0087 or 0.0087 over 1. This is my y over my x. We know my y is going to be, if we go back to our original question, our y was our weekly sales, or x was our customers. It's important to know that. So y is our sales, x is our customers. We'd say for every 1 increase in our customers, sales increase by 0.0087 thousand. What's 0.0087 thousand? That'd be $8.7. Interpret the y-intercept. When x is 0, that's no customers. We'd have 2.4235 thousand in sales. Let's just finish up real quick. We already found the correlation coefficient. It was just the square root of our r squared, 0.955. And the variation was 0.9112 or 0.9119. Sorry, 0.9119. Correlation coefficient tells you your strong positive relationship. Linear relationship. 0.9119 would be 91.2% of our variation in sales, which is our Y, determined by our variation in X. All the same types of problems, just now using formulas and using outputs from computers. Here's your homework. It is a worksheet. I would advise you to get started on it now. And ask questions if you have any questions. Okay.
Yeah, I can't pull it up on my phone, but I